Example 2, find the force required to keep a 50-pound wagon from sliding down a ramp inclined at 20 degrees to the horizontal, assuming no friction. All right, so they're describing a picture, and anytime they describe a picture, I'm going to draw a picture. So I think the key to this is drawing a really good picture. There's a ramp with 20 degrees to the horizontal, and you've got a 50-pound wagon or something on the ramp. So start with this picture. Now, those of you who have taken physics, you might recognize this problem. You've probably done this problem before. I think I'm going to describe it in a slightly different way. Let's see if you like. This better. Okay. We're finding the force required to keep a 50-pound wagon from sliding down a ramp. Okay. So obviously this thing's going to slide down the ramp. But let's look at what the forces are that are acting on this weight. Okay. The first and most obvious is the force of gravity. There is a force that's pulling straight down on this thing. Okay. And so 50 pounds of force is going to be pulling straight down. That's because of gravity. Okay? But there's a second force that's a little bit less obvious acting on this weight. And that's the force of the ramp. Okay? Obviously, the weight's not going to fall straight down to the ground. It's going to slide. And that's because the ramp is also exerting a force. There is a force coming straight out of the ramp's surface, so perpendicular. So you've got one force that's due to gravity, and then this force is due to the slope of the ramp. Okay, so draw that second one perpendicular to the plane. All right? So this looks like the dog walker problem. Okay, right? Dog walker. If this was the dog walker problem, then we could find the resultant force using the parallelogram method. If you've drawn a decent picture, the resultant force should make it slide down the ramp. Okay? So you've got gravity acting on this object, you've got the slope of the plane acting on this object, and then the result is that it's going to slide down the hill. Okay? So we don't want to find the resultant, we want to find the force required to keep it from sliding down the resultant. That sounds an awful lot like the equilibrium. Okay? So there's your picture. And I think it's really, really important to be able to draw a good picture of this. Okay? Everything else is going to be done with right triangles in SOHCAHTOA. So what I want you to notice, I guess, notice this triangle right here. Right? Pay attention to that triangle right there. That is a right triangle. There's a 90-degree angle right there. Okay? We have the hypotenuse of that triangle is 50 pounds of force. All right? Now I also want to direct your attention to this triangle. This is also a right triangle. So just look at this right triangle right now. This is a right triangle. And you see a right angle and a 20-degree angle. And so that means that there is a 70-degree angle missing here. Because the angles in a triangle have to add up to 180. So I know that that angle has to be set. Okay? So then if you look back at your red and green triangle, inside there I see a 70-degree angle and a right angle. Which means that what's the missing angle? 20? 20. Okay, good. So we would know that this angle is 20 degrees right here. And now the good news is, every time you see this problem from now on, you're just going to know that these two angles are going to match. Okay? You don't have to go through that geometry and figure it out every time. You could if you wanted to, but from now on, we're just going to know that those two angles are going to match. Okay? So, essentially what we have, look at your red and green triangle again. We have a right triangle, and we have an angle. If you look at this 20-degree angle, and we have opposite and hypotenuse. So think about SOHCAHTOA. Sine is opposite over hypotenuse. And so this becomes a regular trig equation. Sine 20 degrees is equal to opposite side r over hypotenuse 50. So we have a pretty simple equation to solve. We want to cross multiply, or multiply both sides by 50, if that's the way you want to look at it. We would have 50 sine 20 is 17.1. So the resultant force is 17.1. What's our units? Pounds? 17.1 pounds. That's the resultant. So the equilibrant then, what would the equilibrant be? Negative 17.1 pounds of force. We would need to pull with negative 17.1 pounds of force in order to keep that thing from sliding down the hill. Okay? Again, that negative just implies the opposite direction. 17.1 pounds of force in the opposite direction.